Dear fellow coders, welcome to Unlettered Coder. This is day 15 of Kaggle's 30 Days of Machine Learning Challenge. One important thing to notice is this information from today onwards, whatever I'm going to cover, is not something directed by Kaggle, because Kaggle's Machine Learning Challenge has taken a different direction where you have to participate in active competition. That is only exclusive for people who have registered for the challenge. But I started making videos primarily for those who did not register for the challenge. So I have taken a tangential approach, and then I'm going to cover some of the Kaggle courses that are available on their website. So starting from today, whatever we are going to cover is something that I'm going to show you from Kaggle courses, not directed by Kaggle. That's a disclaimer. Today we are going to discuss about machine learning explainability. So what is machine learning explainability? So this is like a micro course, and in this course we are going to learn what is machine learning explainability, like why is machine learning explainability or model insight important, what is permutation importance, what is partial plots, sharp values, and advanced uses of sharp values. And we are going to start today with the first lesson, which is use cases of model insights. So before even I talk about use cases of model insight, let me give you a quick overview about machine learning explainability. Machine learning explainability is also known as XAI, Explainable AI. So either it is called Interpretable Machine Learning or Machine Learning Explainability, or it is also called as XAI, which stands for Explainable AI. So basically this means extract human understandable insights from any model. So whatever model you build, if you have the ability to extract why such a prediction is made, or at least on an overall level, if you can explain what is going behind the scenes, then that is what explainability is all about. So usually if you one of the videos I think I have also mentioned that usually it is known that linear models like linear regression and logistic regression are more explainable, and complex models, especially ensemble models like random forest, XGBoost, light GBM, CatBoost, all these kind of models are not very explainable. But that is a myth that we are going to break here. So even if these models are not as explainable as linear models, we are going to find ways how we can explain these ensemble models or tree-based models that can give really good accuracy, but usually often ignored by the industry because they are not explainable. That's a myth we are going to break in this lesson, and we are going to learn more. So to start with, today we are going to talk about use cases of model insights. So I will link this in the YouTube description, so you can start with this once again, like typical Kaggle course. If you complete it, the tutorial, and also complete all the exercises, you're going to get a Kaggle certification. So first, in machine learning explainability, the first thing that we are trying to learn is use cases for model insight. Like what type of insights are first of all possible. So first thing that we have to understand is many machine learning models are called black box models, especially like I said, linear models are called white box models, and models that are like slightly above linear models, especially like ensemble models, are usually called black box model. And the reason it is called black box because you cannot read anything inside it, so that's why it's called black box. So even though if they can make good predictions, it's very hard, or people say like you cannot understand the logic behind those predictions. Now imagine you have a single decision tree, you can understand like why such a decision tree is built. But when you have like hundreds and thousands and thousands of decision tree, and those are like combined together, let's say majority voting or something, and then you're going to result, how can you make that prediction? Like how can you explain that prediction? It's a valid question, right? So now this statement is that these models are black box models, is people still say that when they do not know the available methods that we are going to discuss in the next few days, because there are certain techniques these days that are available for us to extract insights from even these so-called black box models, so that they are no more very black box. Okay. So what is this course supposed to teach you? So what features in the data did the model think that are important, or in simple words, feature importance. Feature importance is one of the most important explainability that would say that if features, columns, variables, whatever you would like to call it, so it will tell you what are those important features in your prediction, the model that you built, what are the important features. To give you an example, if you're building a model, let's say to predict movie revenue, did IMDb score play a role? So this is an example. So likewise, you can actually create a feature importance chart and then try to understand what are those features that contributed most to the prediction. So that's feature importance. Second, from any single prediction from a model, how did each feature in the data affect the particular prediction? So one first that we saw is overall at the top level that we saw about feature importance, like overall. And what next we are going to do is for every single prediction, which means if you imagine a test data that you have got, every single prediction is going to be based on the model, right? So now can we learn how did each feature, like if you have got 10 features, how did each feature influence this particular prediction? Like if you are talking about credit scoring, let's say there is a machine learning model that's going to predict whether you should give loan to somebody or not based on whether they would default or not. So it is very important for you to know how each values of features played a role in making a decision whether you should give loan or not. So that is something that we are going to learn in this course. And then the third one is how does each feature affect the model's prediction in a bigger picture sense. So it's very similar to feature importance. So to give you the keywords that people usually use, the first one is usually called feature importance, like what are the features that the model think is important. The second one is called local interpretation. Local interpretation refers to every individual prediction and how you can interpret it. And then the third one, how does each feature affect the model's prediction in a bigger sense. So this is called a global interpretation. So you try to globally try to understand how these predictions are made by your machine learning model. So that's what we're going to learn in this course. And before even doing that, first we need to understand, I strongly believe, why machine learning explainability or machine learning interpretability or explainable AI is important. See, before even we want to do this thing, first we need to understand why is it important. Does every data scientist do this thing? So I can probably approximately give you a ballpark figure that a couple of years back there was a Kaggle survey, and in the Kaggle survey not even 50% of data scientists were doing machine learning interpretability at that point. So like now machine learning interpretability as an ecosystem has developed a lot, but the point that you have to remember is still not everybody does it. Some people who are very religious about showing explainability, or some business that demands explainability, they would do it. But do you know if if you go to a data scientist and talk to them, you can ask them like how many times, like if you see how many times they built a model and then they also cared about explainability. So that number is very low. So for us, even to infuse this culture in data science community, it is very important for us to first believe or value why these insights, why this model insight is very important for us. So once we know this thing, then we will realize that, oh, probably for these so and so reason, for me it is very important to build a machine learning model and also to explain it so that so and so reason is fulfilled. So that's what we're going to see next. What are the reasons? The overall level, first debugging. The second reason is informing feature engineering, like how to do feature engineering. The third is directing future data collection. The fourth is informing human decision making. The fifth is building trust. Let's look at one by one, step by step, and then I would also include one final reason or factor that is not listed here, which is legal and risk and compliance. So we'll also quickly look at it at the last. So first let's talk about debugging. Now when you talk about debugging is a very important component in software development lifecycle. So if anytime you talk to a software engineer, writing unit test in their code and then trying to avoid bugs, like catch exceptions, and also after something goes wrong, debugging is a very important part in a typical software development lifecycle. But if you usually see, data scientists may not follow a typical software SDLC model, but you need to also realize that data, when we deal with data is sometimes like the data that we get from real world is highly unreliable, very disorganized, and generally dirty data, which means it's not clean. It's not like your typical Kaggle competition where you get a decent CSV. Sometimes you have to do web scraping. Sometimes the data is not clean enough. Sometimes there are values that you do not expect. So suddenly all of a sudden sometimes you would see like -99 for age. Like, is it possible that there is a human being who is living backwards 99 years old? No, it's not possible, but such data might occur. So debugging is very important, because when you are going to build a model, so you are going to do pre-processing first, and also you're going to potentially avoid a target leakage. So there's a chance for target leakage, which we saw in the previous video. So because of these reasons, it's very, very important, or it is quite common for a machine learning model to have errors. So it's not uncommon. So it's not uncommon for your model to have some kind of error, because there is a very high chance or probability that you might have actually missed something while you're building the model, and that is an error that has occurred, and it's not something strange. So given the frequency and potential consequences of such bugs in machine learning model, debugging is one of the most valuable skills in data science. Not everybody appreciates this. So for you to do this thing, it's very important for you to understand how a model is actually, like what kind of patterns model has looked, what kind of things model has used to make this prediction. So then you can actually compare it with your domain knowledge, that the knowledge that you have got from your business. For example, if you remember about the example that we saw in the model leakage section, so one of the important lessons that we learned is there are some columns that are filled after the target variable is calculated. For example, if somebody had got pneumonia, then there is a column that is filled whether they took antibiotic for pneumonia. So somebody would take antibiotic for pneumonia only if they had pneumonia, which means this knowledge you would not get otherwise if you do not have business knowledge. So like that knowledge like this, so once you understand what is your model is using to predict something, then you can actually compare it with the knowledge that you have got from the real world, and then you can easily track down the bugs that might be ruining your machine learning model, either on overfitting side or underfitting side, whatever side is. So debugging, understanding model insights really help in debugging. The next thing is informing feature engineering. Feature engineering, as we have already spoken about high of, feature engineering is usually the most effective way to improve your model accuracy. So you can build a simple model, baseline model, then you can build a like an ensemble model, then maybe you can do hyperparameter tuning, you can find the best model, you can have the best cross validation strategy. Even after you do all these things, if there is one technique that can help you improve your model accuracy, that is feature engineering. Feature engineering is nothing but if you think combine or use multiple features and then arrive at new features, and that feature that you're going to use to model prediction. So where this new feature might influence your model prediction or improve your model prediction than the existing features. That's what basically feature engineering is. So there are two ways you can do feature engineering. One is like your typical mathematical way. So where you might do transformations, you might take polynomials, you might do something like addition, subtraction, and then come up with features. The second method is you have your inherent business knowledge. For example, everybody almost might know that if I have a date column, maybe it is good for me to extract whether it is a weekday or a weekend and then try to use that as a feature. So this is one of the common things that people would do. So this comes from my intuition or knowledge, business knowledge that I've got, because maybe let's say I'm trying to predict a sale or something. So the sale in a weekday might differ from a weekend. So rather than keeping the date column as date column, if I actually extract a new feature from that, it might give my model more points to learn. So this is one way. So the other way is doing mathematics, like a mathematical way of extracting features like transformations or polynomials, like anything of that sort. So there is an example that Kaggle has given here, which is like one of the competitions that happened, which is called the loan default competition, to predict whether somebody would default their loan. So in that competition, there were like about 100 features, and the features were like masked because of privacy reasons. Like the features were like F1, F2, F3. So now in this kind of world where your features are masked, where you don't know what feature it is, it's very hard for you to use your business knowledge, because now you do not actually know what does it mean. So now, but what has happened is one of the Kaggler has actually found out that when you subtract two features, which is especially F527 and F528, it actually in fact created a powerful new feature, and that feature made model prediction more accurate, better model prediction than the models built without this new feature. So now like if you think about it, like there are two features, and then you can actually create a new, like what they call as like a golden feature with the two values that you know. So now how do we know what all these features to use even for trying feature engineering? And that's where model insight come into picture, because once you build a model, let's say like a baseline model, and then you have understanding about what is happening with the current model and what kind of features are used in this, what kind of features are very important for this model. Now you can actually try to combine these features and then come up with the new features. Like, so for you to even first know, okay, I have to pick 527, I have to pick 528, like the example column names, the features, you need to have model insight understanding so that you know which column to pick, because otherwise you might have like hundreds and hundreds of columns. It may not be easier for you to pick. So pick up the important features. Again, important features or model interpretation can help you in informing better feature engineering than arbitrarily doing something like out of nothing. The next important thing is directing future data collection. So future data collection, if you think about a typical data science problem or a workflow in a typical organization, unlike a setup like a Kaggle or any other hackathon medium. So in a typical data science workflow or setup, it's not just you're going to build a model with existing data. Sometimes you have to procure data. Sometimes your business might ask you a question. Okay, like I've built a preliminary model, but you might say that this data is not good enough. Like I don't have enough data. So then the next potential question that anybody might ask is like, so what is good data? Like what kind of information you want? So now when somebody asks you a question, what is the future data that I need to give you? Like for example, if you are in a marketing analytics, you are trying to predict whether there is a campaign that might get converted or not, whether there is a lead that might get converted or not at the end of a campaign. So you have to start at the start of the campaign to tell them like this is the information that your tagging team or the agency should capture, so that I can use and make a better prediction for you to now come up with that particular feature. You need to actually have that understanding about what kind of things are used, or like how your model is making that prediction. So model based insights can actually give you a very good understanding about the value of current features that you have got. So which means you can actually use this reasoning and then give them an idea about, okay, let's say like this feature, for example, like when did they receive an email? So let's say this is a campaign, and when did they receive an email is a very important feature for you. So now if this is an important feature for you, so now like when did they receive an email is important. So now you might also assume that, okay, maybe my vendor is only capturing date, or my analytics team, the technical tagging team, engineering team has only tagged date, but I can also tell them to tag an hour, like the timestamp as well. So now how do you know like how to say timestamp, or even if you have to say that, you have to make a business case, right? So for you to make that business case about future data collection, either you are going to collect data or somebody else like product team is going to collect data, it's very important for you to make that case. Again, if you're working in data, everybody is going to ask you data, why did you even make such a comment? So for you to make that case, model based insights is going to be extremely helpful in for you yourself understanding that thing, and also advocating somebody else to implement something new in a product or analytic event or whatever it is. So how to direct future data collection, that direction comes from model insight, and also it helps you make a business case. One of the most important reasons I would pick out of all the factors is informing human decision making. Humans are not machines. Like if you take any organization, and every organization, you go up in the chart of the organization, their technical skills might go down. So there is no offense for anybody. I'm not making sarcastic statement, so I want to be realistic. So a data scientist technical skills might be completely different from a business functions leader skill. Okay, so now if you're going to present something to your business leader, that business leader, he or she is not going to care about the amount of accuracy that you have got, AUC that you have got, F1 score that you have got, or RMSE that you have got. Like they are not going to show interest in of course they would be happy to see, oh, this is the X percentage of accuracy that we have got, like our data science team is really, really awesome. So they might value that, but what would be more important for them is to actually tell them like what is happening in English. Like you have to tell them like in English or whatever language that you communicate within your organization. You have to explain it in the language that they understand, rather than using your statistical or a data science language. Let me give you an example. The example that I'm trying to give you here is, for example, like the same example, let's take the same example in a marketing analytics setup. If you are going to go to your marketing manager and tell them like XXX, these are the customers have higher lead conversion score. Let's say this is what I'm going to say, tell my marketing manager that following customers have higher lead conversion score. So now the next immediate question is like, how did you come up with this thing? I can simply, flaunt saying like my machine learning model, built this, or even the follow-up question like, how did your machine learning model do so? Or I myself say that, okay, these are the customers who have, let's say, like clicked 5 times at least, and opened it on a Sunday and opened it at 9 p.m. in the evening. And we have learned from our machine learning model that anybody who has this kind of pattern, this is the insight that we have got from our model. So anybody who has this kind of pattern is highly likely to convert. So that's why we have ultimately said that these people have got higher conversion rate. So for you to make a comment like this, for you to help human decision making, so then what the marketing manager would do, the marketing manager might advocate their team to actually, stick to a rule or create an SOP where they might follow a similar pattern that you identified, the insight that you found out from your existing model. And for you to do this, for you to help a human being who is usually either you or your business stakeholder or somebody else, like a client or somebody, it's very important for you to advocate that. It's very important for you to have model based insights or the interpretable machine learning model that you have built that can actually help you. So the example that Kaggle has given in this case is, if you go to Amazon or any e-commerce website, you would see a lot of recommendations, and those recommendations are not human curated. Like nobody is sitting and making those recommendations. But how would they have built that recommendation in the first place? They would have built that recommendation in the first place using some insights that they use from your purchase behavior pattern, which probably was already a model. So any new decision that's going to be made by human beings, you cannot simply, just simply say that machine learning model did it. Rather than that, they would always expect some kind of explainability as part of that, which is very important for any business stakeholder. In most business that affect individual customers, this is quite important. So informing human decision making is one of the very important reasons why you should have an interpretable machine learning model or explainable AI model or machine learning explainability. So like they say, for these decisions to be made, the model insights can be really more valuable than the actual predictions are made. And the last reason that Kaggle has given is building trust. Again, trust is another thing. So in a lot of companies, a lot of organizations, your data science team or machine learning team is like a cross-functional team. So it's going to work with a lot of different teams. Like you could be a marketing analytics team, or you could be like a customer data science team, or you could be, let's say, like a product analytics team, or you could be a machine learning team with an engineering, you could be a machine learning team with a networking team. So you, as a data scientist or machine learning engineer, if you're working somewhere, you are always going to be part of somebody else, unless you work in like Facebook artificial intelligence research or Google, or they are working on a different purpose altogether. Their purpose is probably to improve the machine learning landscape, but a lot of applied data scientists and applied machine learning engineer, they are going to be part of a cross-functional setup. So if you want to make your stakeholders believe you, if you want to, in fact, like I'm not talking about stakeholders, your partners or your peers believe in you, then for you to earn their trust, it's very important for you to actually show them some kind of understanding about how the machine learning model is functioning. Otherwise they might think that you copied something from Stack Overflow, just pasted it and that you did model.fit. So there is a running joke, right? So in data science community, that all I do in my life is model.fit. So if you see the scikit-learn universe, so model.fit is how you actually fit a model. So this is a running joke. Like a lot of data scientists actually do not understand what is happening under the hood, but just copy a bunch of codes from either Kaggle notebook or a Stack Overflow and then just paste it, and then they get like a decent enough accuracy, because of course, like accuracy is not very difficult to gain, and in real world it doesn't really matter a lot between in most business sense, if I would say, between 78% and 75%. So that delta wouldn't mean much, but what would mean more is for you to earn the trust of your team members, how efficient or how good you can explain that model and then make them feel that you actually know what is happening. So building trust or gaining trust, earning trust from your peers or from your stakeholders is very important, and the model explainability, machine learning interpretability is really a hallmark factor for you to gain that. Okay, so these are the reasons that Kaggle has given. Another very important reason that I would say, which is not covered here, is legal risk and compliance. In a lot of countries, especially if you talk about GDPR, there is a clause within GDPR that talks about right to explanation. So if you talk about right to explanation is a clause within algorithm regulations, especially in the realm of artificial intelligence and machine learning, where an individual can seek explanation from a company for something that has happened to them. For example, let's say like I have applied for a loan and I've been denied the loan. So now I go to the bank and then I ask the bank, like, why is my loan denied? Now the bank manager or customer support executive, whoever it is, going to say that your loan was rejected because our machine learning model said so. Now this is a terrible explanation to say, first of all. But if somebody says that, then my next question would be like, can you tell me on what basis your machine learning model made the decision? If they do not give that answer, I have every right to take them to the court, because right to explanation is the thing. I'm not sure how many countries have already implemented this thing, but it is available. There are a lot of brand impact in this thing. For example, if a company implements such a thing like industry scale machine learning model, and if they do not have enough reason to enough data or enough ability to explain such a call, that is like we talked about local interpretation, right? Taking a particular data point, taking a particular prediction, and then saying what are the factors that influence in this particular prediction. If a company cannot do that, they would face two kinds of issue. One is the risk and compliance or legal issue. The second is the branding issue. Like imagine like now that customer is a social media influencer and they go and write about this company on social media. For example, you can go online and then search about DHH, the creator of Ruby on Rails, what he said about Apple credit cards, which Apple launched. So just search about DHH Apple credit card. That would give you some idea about what kind of a PR disaster it could become when your company cannot actually explain a prediction. So for legal reasons and also for your branding reasons, like brand value or reputation, it is very important for you to actually build and deploy the models only that you cannot understand. Like there are a lot of cases where you might have built a model and then deployed that you cannot understand. So take the recent Twitter cropping algorithm bias, for example. So there was a bias in the cropping algorithm and nobody knew until some random person on Twitter found it out, and that became a PR disaster for Twitter. So if you want to avoid these things, also somebody can sue like Twitter for this thing, right? Like for discriminating one race over another race. So for you to avoid these things, like either legal or risk and compliance, or also branding, PR, reputation related thing, it's very important for you to have interpretable machine learning in place. So that takes us to the end of the first lesson. So in the future classes, future sessions, we are going to learn about different methodologies, how to do this interpretation. But to quickly summarize, like we are trying to learn about why machine learning interpretability or explainability is important. We learned that it's very important for debugging. It's important for informing new feature engineering. It is important for us to direct how to collect data in the future, like tag analytic events, like for engineering team or product team. The most important thing that I would say is informing human decision making with actually explainable insights, rather than just simply giving them a score, and building trust with your stakeholders and peers, and finally your brand, PR, or risk and compliance reason. So these are the reasons why it's very important for you to build an interpretable machine learning model, and it is not that tough. Like there are a lot of out-of-box libraries that can easily do it for you in a couple of lines of Python code, and that's what we are going to learn in the future section. So if you have any comments, please let me know in the comment section. Otherwise, I hope this video was helpful to you in starting your machine learning interpretability journey. See you in the next video.